Hey, so this is problem 6 on the review packet. So the first one is a fairly standard problem. We're going to start from the right side and go to the left. So the first thing we'll notice is that two resistors are in parallel with each other. All right, so we can call this R1, and we'll say 1/28 plus 1/6. And that's going to give us something like 4.9. So now, for convenience sake, I'm going to redraw this section with that resistor so that hopefully you can see it a little better. So that would become like that, and that would be 4.9. So now we notice that these two are in series, so we can just add them together. And that equals 19.9. And again, we'll remove that section and combine them together. All right, and then it should become obvious at this point that these are in parallel. So we can say, oh, R3 is them combined in parallel. So 1/19 plus 1/19.9. That's equal to 9.73-ish. And then finally, one more step. We combine these together. So now we've got this whole section, which is equivalent to this 9.73 resistor, and it's in series with the 60. So RT is 60 plus 9.73 equals 69.73. Just like that. Now, I know you won't be able to erase the circuit in real time during the exam, but you can always just redraw it on your own if it helps you understand it. Or you can just try to do it in your head. It's not too much to keep track of, as long as you keep everything organized. Labeling the resistors R1, R2, R3 can help a lot. So the next part B, we're going to do the same thing. We're going to start from the right side. So we notice that the 28 is in parallel with the 10 and the 20 together. And we know this because they have the same top and bottom nodes. So we'll say R1 is equal to 28 plus the 10 and 20 together. And that's equal to 14.48. All right. And we'll replace that section with our 14.8 resistor. Sorry, 14.48. All right, so now we're looking at this next section, and we're going to say, oh, well, I know that 14.48 is in parallel, or actually it's in series with this 16, right? Because I have my 14.48 here, and if you see current flow, it's going to go through both of them. So that means that I can just combine them, add them up, and that gives me 30.48. So now I can replace this whole section. The 30. All right, so we're going to do two sections at once now. The red section we know is in parallel, the 50 and the 30. And then the blue section, they're in parallel, right? The 22 and the 32. So we'll say R3 is 50 plus the 30.48. And that equals 18.94. And then on the other side, we've got the 22 and the 32. And they're roughly equal to 13.04. So now we'll redraw the circuit. Here's the 25. 25's here. And then we've got our 18.94 and our 13.04. Now what becomes apparent is this 18 and the 13 are in series with each other, and the 25 is in parallel with them both. So that means RT is going to be equal to 25 plus rather 1 over 25 plus, and then you just add the other ones up underneath. And that's going to be equal to 14.03. Lastly, we have part C. Part C, you just solve in a similar way, but this time you're going to have a reference point in the middle. And all that does is kind of change the directions that you go towards. So on the right side, we have 3 that are in series, and they're in parallel with the 18, right? If you don't see it, it's in red right here. So all we have to do is add them together. So we'll say that R1 is equal to 1 over 18, and then that's plus 1 over all 3 of those together. And that part is equal to, let's see here, 11.35. And then this part in blue, they're all in series, so they can be combined. R2 is equal to 24 plus 18 plus 4. That's equal to 46. So let's do some combining to make it look a little bit better visually. We'll just get rid of all this. And we'll get rid of all of this. And we'll replace it with a nice 11.35 and 46. Now, the 12 and the 11.35 are obviously in series relative to this point right here. So that means you can combine them. We can get rid of that part too and simplify it. And we'll end up with a 23.35 on one side and a 46 on the other. And they're in parallel. They share the same top and bottom nodes. So all we have to do is say that RT equals the parallel combination of them. 46 plus 1 over 23.35. That's 1 over that. And we'll end up with 15.444. And that is the entirety of problem 6.